Okay, so welcome to part 2 of Unit 3.5, Solving for a Variable. So now we have situations where there might even be more than 2 variables. So in the first question, we've got 3 variables, but it all works the same way. This is the only term, the 2a is the only term that has an a in it. We're trying to solve for a, so that means isolate a. So we first need to get that 2b over to the other side. So that becomes k minus 2b, and that equals 2a. And then divide both sides by 2. And so we end up with a equals k minus 2b over 2. You can leave these ones like that. For part B, on the right-hand side, we have a term that has an A, a B, and a C in it. So to get rid of the B and the C this time, we need to divide by B and C, because when we see A, B, C together, that means multiplication. So to undo multiplication, we use division. So the B and the C will cancel out. We're left with an A on the right-hand side, and so on the left-hand side, we have M over BC. Part C is just like that one. We want to isolate the A in this term. So the A is being multiplied by 2 and by pi, so we're going to divide that by 2 pi. Divide the right-hand side by 2 pi. The 2 pi's will cancel. So A equals C over 2 pi. And for the last one, we're trying to get this A by itself. It's being multiplied by B and it's being divided by 2. So let's get rid of the dividing by 2 first. We can just simply multiply by 2. That gets rid of that. So that gives us a 2A equals AB, and then divide both sides by B, so A equals 2 capital A over B. Remember, capital letters and small case letters are different. Now your other option for this question, if we had A over AB over 2, we could do this with a common denominator. So this A currently has a denominator of 1, so to give it a denominator of 2, we'd have to multiply by 2, which means we have to multiply the numerator by 2 as well. So that gives us a 2A over 2 equals AB over 2. Now take the entire equation and multiply it by 2, so your denominators all cancel out, and we're back to where we were here. So divide both sides by B, because it's the small case A that we're trying to isolate. So A equals 2A over B. Okay? So now let's take a look at this last example here. So this is a word problem. And with a word problem, we want to take and we want to use variables to represent the things that we don't know. So a parking lot charges $15 to park a car, that's important, and $25 to park a bus. The total amount collected was $2,685. Write a linear relation. So a linear relation is an equation just like we just had. The fact that it's linear is just because there's no exponents on the variables, and the variables also aren't being multiplied together. Express the total revenue for the lot in terms of the number of cars and the number of buses. So these are the two things that we don't know. We don't know how many cars and we don't know how many buses are in the parking lot. So we're going to let a variable represent each of those things. So let's use C be the number of cars. In my lifetime, that symbol right there is number. It's not hashtag. Okay, so that's the number of cars. Then let's let B be the number of buses. So now we can start making an equation. If it costs $15 to park a car, and let's say you parked 5 cars, so to calculate the total amount of money, you would do 15 times 5. So if it was 5 cars, you would do 15 times 5. But the problem is that we don't know that it's 5 cars. All we know is that it's C cars. So the total amount of money brought in by cars would be 15C. So this is the dollars for cars, the total amount of money for the cars. And since it's $25 to park a bus, and we have B buses, so 25B, that's the total amount of money that you bring in for buses. So let's say 10 buses parked. You would do 25 times 10, and that would be $250. I don't know if buses is supposed to have 2 S's or 3. So if we take how much money we brought in for cars and we add the amount of money that we brought in for buses, that will give us the total amount of money, which is $26.85. So this here is your final answer for part A. It's a linear relation. It's an equation that shows how the number of cars and the number of buses relate to the total amount of money. Now for the next question, we want to, I'm going to go back to pink again. For the next question, we want to write the equation to express the number of cars in terms of the number of buses. Now that big phrase just means isolate C. So we'll go back to the equation. 15C plus 25B equals 2685. We want to put the B over on this side, so 15C would be 2685 minus 25B. Divide both sides by 15. That cancels with that. So C equals 2685 over 15 minus 25B over 15. This number turns out to be, let's see, 2685 divided by 15 is 179 minus 25 and 15 are both divisible by 5, so this is going to be a 5 over 3b. So C equals 179 minus 5 over 3b, or 5/3 b. So the next question says, express the number of buses in terms of the number of cars. So what that means is isolate B. So get the buses by itself and have it as an equation of B equals something, and on the other side of the equation there's going to be the C. So let's go back to 15C plus 25B equals 2685. This time we want to isolate this term, so the 15C needs to go over to the other side. So 25B equals 2685 minus 15C over, minus 15C. Sorry, and then all of this is going to be over 25. So B equals 2685 minus 15C over 25. Now, this doesn't reduce nicely like the last one did. 2685 divided by 25 is not a nice number. So I'm just going to leave this one like this. We could divide everything by 5. All three of these, here, all three of these, the 2685, the 15, and the 25, are all divisible by 5. So we could actually do that. We could divide them all by 5. If they weren't all divisible by 5, then we wouldn't be able to do this. So I'm going to divide everything by 5. So 2685 divided by 5 is 537. 15 divided by 5 is, so I'm dividing the numerator by 5 and I'm dividing the denominator by 5, which means I'm not changing the value of the fraction, I'm just reducing it. So this is going to be 3c, and then this is going to be over 5. Okay, now the last question says find some possible combinations for the number of cars and the number of buses in the lot yesterday. And that's just a lot of guess and check. However, we can make it a little bit easier on ourselves. So we would just have to find numbers for C and find numbers for B, so that when you take 15C, let me see, when you take, let's use blue. When you take 15 times some number and then add 25 times some other number, or it could be the same number, I don't know, you're going to get 2685. I'm actually going to leave that for you to try. No, I changed my mind. I'll go through it with you. So what we have then is, if we take and we use this formula here, and now I'm going to go here. Oh, didn't work. Okay, well, we'll try this then. So if we take this formula here, C equals 179 minus 5/3 B. If we use values of B that are all multiples of 3, then that's going to eliminate this fraction right here. It's going to get rid of it. So I'll show you. For example, let's let B equal 3. So then we get C equals 179 minus 5/3 times 3. The 3's will cancel, so that just becomes 179 minus 5, which is 174. So if we have 3 buses, that means we have 174 cars, and the total cost will be $26.85, like we want it to be. Or if we let B equal, let's say, 6. So then C is going to equal 179 minus 5/3 times 6. The 3 and the 6 will cancel, so that 6 will become a 2. So that'll be 179 minus 10, so that means that C is going to be 169. So when there are 6 buses, there are 169 cars. Now I'm just going to do a little table here. So this is buses, this is cars. So when the buses is 3, the cars is 174. When the buses is 6, the cars is 169. What I would like you to do is to find at least 2 more scenarios that will work for this. And that's the end of this lesson. So stay tuned for more online lessons, and thanks for listening and watching.